Hello everyone, so in this video I want to look at how do we write solubility constant product expressions. So remember, solubility products are of course those of so-called precipitates and how they go into solution. So we're asked to write the solubility product constant expression for two salts, the first being iron 3 hydroxide. So iron 3 hydroxide, we first have to figure out the formula. So iron 3 means it has a 3 plus charge, hydroxide has a 3 minus charge. So that means there are 3 hydroxide ions for every 1 iron. And of course it's a solid, and that is in equilibrium with iron 3 plus aqueous plus 3 OH minus. Right, so that's the equilibria we need to consider to be able to write the solubility product constant. Right, it's kind of simple, or meaning once you've figured out what the balancing of the formula needs to be, so meaning 3 hydroxides for every 1 iron, so there's 1 iron to the power 3, that's what the 3 means. And then of course the 3 corresponds to the 3 in the formula, right? That means our KSP is going to be equal to only the things that can have concentration. So KSP is an equilibrium constant, so that means we need to take into account all our rules regarding equilibrium constants. So that's only things that have concentrations and no solids and liquids. Right, so we must also recall that it is product concentrations divided by reactant concentrations. So our products in this case, of course, is the iron concentration and the hydroxide concentration, and our reactants is this solid. So in principle, it is Fe3 plus concentration at equilibrium. I mean, you can specify it's at equilibrium, but you don't have to. Multiplied by the hydroxide concentration to its stoichiometric coefficient. So in other words, hydroxide concentration cube. So that's the product. And the reactant, because it's a solid, we designated a value of unity, a value of 1. Right? So that means our expression is just simply Fe3 plus multiplied by OH minus cubed. Alright, and the 1 is implicit because it is in the denominator, so it gets absorbed in the expression, and so it's implied that those two concentrations form the solid, right? So you can remember that. Cool. So let's look at B. It speaks about calcium phosphate. So calcium has a 2 plus charge and phosphate has a 3 minus charge. So that means the species that we are considering here has to be Ca3PO4 2. That's a solid, and it forms an equilibrium with 3 calcium 2 plus ions plus 2 phosphate 3 minus ions. Alright, and like we did at the top there, so we can write its KSP, solubility constant product, and that's going to be the products over the reactants, right? And I'm not going to do the one thing again because you can see it's just a solid, so meaning we can just skip ahead to what it has to be. So only things that have concentration, so that's the calcium ions, and remember it's stoichiometric coefficients, and PO4 to the power 3 minus, and there's 2 of them, so they're stoichiometric coefficients. Alright, so that's the important part. The 1 is implicit because it's a solid, so when you see that, then you can remind yourself of that, and you must remember your stoichiometric coefficients for them. Okay, Anytime when you see ions like this, and then you must know the ions recombine to form the solid. That's a simple thing. So if you see ions in an expression like that, you know the ions combine in some ratio to form a solid. I mean, that's kind of a giveaway of what KSP is always for. Okay, but this was about writing KSPs. So I hope you can write KSPs now. Just a reminder of, stoichiometric coefficients need to be the powers. And then, of course, you only include things that have concentration. So that's very important. Right, I'll see you in the next video.